When we left our reimplementation of the Unix tail command, we had found a way to backtrack through a file a chunk at a time and then locate the beginning of the 10th to last line. We located the line by finding the new line characters in each chunk. Now we need to print the last 10 lines to the console. At the end of the loop execution, we have a chunk of text in memory and an offset for where the 10th to last line begins. So an obvious place to start would be to dump that chunk to standard out, starting at the offset. This is great, but we can see where the chunk abruptly cuts off. What about the chunks we already went through and discarded? One way we might go about it is to redo our loop so that it saves references to the chunks of text somewhere as it reads them. Then we could just go down the list of previously read chunks. But before we launch into it, consider the downside of this approach. Supposing we accidentally fed a 1 GB binary file into our version of tail, and that file happened not to contain any new lines. Because it would keep searching back to the very beginning of the file, and because it would save every chunk it read in memory, the process would quickly grow to more than a gig in RAM. As a general rule, we prefer to avoid solutions with the potential to grow in memory as a direct function of the input size. Let's take a minute to go over the state of the program at the end of this loop. Quick post-production note, the 512K in this illustration was a mistake. It should have just been 512 bytes. We've searched backwards, chunk by chunk, through the file. We have one current chunk in memory. Reading that chunk in moved the file object's offset to the end of that chunk in the file. Another way to say this is that the file offset is currently positioned where the current chunk leaves off. Which means that, in order to write out the rest of the lines to standard out, all we need to do is read forward from the current file offset and print the result. The most obvious way to do that would be to simply call read on the file object, reading in the rest of the file into one string, and then print out that string. Unfortunately, this has the same problem as our chain of chunks idea earlier. It grows memory use linearly with the size of the remaining section of the file. If we want to do the dump efficiently, we need to do it by chunks, the same way we read the data in the first place. We can do this with a loop that reads and writes chunks of data until the source file is exhausted. But there's an easier and more efficient way to do this. Ruby 1.9 introduced an io.copyStream method. We can invoke this method with a source and a destination, which should both be I/O objects. It will copy data from one to the other in an efficient fashion. It respects the current offset of the source, so the read will begin at the position we want it to. This isn't just a reduction in the amount of code. In my own informal benchmarking, I saw close to an order of magnitude improvement in performance when using copystream instead of my own handwritten copy loop. The next time we revisit this code, we'll look into cleaning it up and making it a bit more like idiomatic Ruby and less like C code. But for now, we can be happy knowing that we've successfully cloned a small piece of the functionality of tail. Happy hacking!